Hello everyone. So today I'm back with another problem, and this problem is here. It is saying that consider a thin circular disk of radius r having a uniform surface density sigma. Calculate the potential at any point on its circumference. So let us draw a picture first. That will be, let us, I'm not very good at drawing pictures, so please pardon me for that. This is a circle. I hope, yeah, it's more like a circle. And now let's draw. This is its diameter. This is radius r. This is also r. So this distance is r. Okay. So the total is 2r. Anyway, this is the point O, and let us consider from this point we take a strip here. Okay, this is theta angle, this is d theta angle, and this strip is ds. Okay. So that's all. This ds is the surface element that we considered here, and if I increase this up to the circumference, if I increase this line up to the circumference, then the whole line will be r cos theta, because this is the 2r cos theta. Sorry, this will be 2r cos theta, because 2r cos theta, as this is 2r, this total diameter, and this is theta degree, and so this line will be 2r. Well, let's consider the scenario here. Okay, so if this is a circle, yeah, hopefully this is a circle, and this is the diameter, and then any angle made by these lines, it can be, this point can be anywhere in this upper half or this lower half region. This angle will be 90 degree. This is a theorem that we did in junior classes like class 9, and this can be proved. So here this is 90 degree, and we have this theta d theta, this theta angle here. So if this line, the total line is 2r, the length of the total diameter is 2r, so what is this line, the length of this line? Okay, so here I can say that this is actually nothing but we can say it 2r, this line is, the length is 2r cos theta. How can that be? Because cos theta, you see, cos theta is nothing but base by hypotenuse. Okay, so this is the base here, cos theta. If this is the cos theta, then base is this line, and this is the hypotenuse. Let us consider this, the length of this line is L, so that will be base by 2r. And if we write 2r cos theta as this line, so we have 2r cos theta, and that will be 2r into L by 2r. So 2r 2r will be cancelled, and this L, this length, that will be left out. So if I write this line as 2r cos theta, that will be equal to this length. So I hope you understand. This thing, I have used this idea in the math, in the problem. Now let's continue. First, let us consider this ds surface element. Okay, so ds surface element, that means ds is equal to r d theta dr. So how can we get that? That is, let us consider this is dr, this increment is dr, and this is r d theta, because as we know that s is equal to r theta, where s is the part on the circumference and r is the radius and theta is the angle. This is the formula. So from there we can get this part, and that will be equal to r theta, and r will be just this much, that will be r, and theta will, in this case theta will be d theta. So this s, if I consider this as s, that will be r d theta. So the surface element will be dr into r d theta. So that is here, just here. So now let's consider the potential at this point due to this surface element. That will be, let us say that d phi will be equal to 1 by 4 pi epsilon naught sigma ds by r. Now the thing is, and this line is r, we can say that this line is r. Anyway, the total line is 2r cos theta here, and this line up to this element is small r. Okay, so how can I get this? So the question is, we know that the uniform surface charge density is sigma. That means sigma is equal to, if q is distributed in the whole disk, then sigma is, and s is the total density, s is the total charge, total surface. So sigma will be q by s, that is density, surface charge density, and here in this region s is ds. So that will be, so we can, and we can assume that there is a dq charge, so we can write this. So we get dq is equal to sigma ds, and for this this is only a part of the whole disk. So this will only contribute to d phi. Phi is, if phi is the total potential at the O point due to the whole disks, and then this part will only contribute a little, that is d phi, and this will be dq by r, and in the region of dq I have written sigma ds. So you get it, and by integrating we get 1 by 4 pi epsilon naught sigma. Now that will be a surface integral where the limit of theta will be from minus pi by 2 to pi by 2, and limit of r will be 0 to 2r cos theta. Now ds, we can write ds as this sigma is outside of the integral, as it is a constant. ds is, we know here, r d theta dr and r. So these r's cancel out, and we can so here we are. Now the limit is okay, wait, first this dr will, if we integrate this dr, we will get only small r, and upper limit minus lower limit. If we do that, we will get 2r cos theta minus 0, so that I am not considering that d theta. That is it. Now the thing is that Why this limit? Let us see that in this picture, when this is the theta angle, okay, this is the theta angle in anti-clock direction. So if I consider the minus pi by 2 angle, that will be like, that will be from here, minus pi by 2 is the extreme end. This is the minus pi by 2, okay, and plus pi by 2 will be extreme 90 degree from here, so that will be this. So starting from this region, it is rotating totally to complete to cover the whole disk. So it is starting like this and then rotating to cover the whole disk. So the limit will be minus pi by 2 to plus pi by 2. This let's do the thing now, the rest of the math. Well, 2r will be outside, cos theta d theta, that will be sin theta, and minus pi by 2 to pi by 2, that will be theta. These cancel out, theta r by 2 pi epsilon naught. Okay, sin theta will be 1 minus of minus 1, as sin pi by 2 is 1 and sin minus pi by 2 is minus 1, so upper limit minus lower limit, so 1 minus of minus 1. Then we know this will be 2 and this is a 2, so these will cancel out and we get finally so this is the answer to the question. So at any point, that is, we consider O as this any point, this can be anywhere on the surface, on the circumference. So the total potential will be due to the whole disk will be here phi is equal to sigma r by pi epsilon. That's it. So if you like this video, then please comment below, like and subscribe to my channel for more videos like this. See you later with another new question. Thank you.